Okay, today we'll do Gauss divergence theorem. The Gauss divergence theorem says that if f is a continuously differentiable vector point function and V is a volume bounded by a closed surface S, then double integral S f dot n ds is equal to triple integral over V del dot f dV. So the main thing about the Gauss divergence theorem is that it connects the double integral with the triple integral. So here we have a question to understand it better. Verify Gauss divergence theorem for f is equal to 2xyi plus yz square j plus xzk, where S is the total surface area of a rectangular parallelepiped bounded by these planes. X is equal to 0 to x is equal to 1, y is 0 to y is 2, z is 0 to z is equal to 3. So if we have to find the double integral, then we have to find the surface area of all the 6 faces of the parallelepiped, which is a very lengthy process. So we'll calculate the right hand side first. So right hand side will be triple integral over V divergence of dV. dV means it is dx, dy, dz, where we have got the range of x, y, z. So before that we need divergence of f. Divergence of f will be the derivative of the I term with respect to dx, and the next term will be derivative of y j term, the derivative of the j term with respect to y, and the third will be the derivative of the k term with respect to z. So we found divergence f, which is this term, and then we have integrated this term with respect to z. So when we integrate this term with respect to z, we'll get 2yz, which is written here, z cube by 3, which is written here, and xz, which is written here. Okay, so this limit is not 1, this limit is 3. So when you replace all the z values by 3, this is what you get, 3x plus 6y plus 9, which again have to be integrated with respect to y. Okay, which gives you this function, which is 3xy plus 6y square plus 9y between 0 to 2. Okay, put the limits wherever you have y, put the limit as 2. So you get this. Again, do the integration with respect to. So after you finished with y, you don't have dy here. You have only 6x plus 30, which you integrate with respect to x again. And then you get the answer 33. So your value will be 33. Now, we do the double integral over all the faces. So we have the first face ABGF. You can see along the rectangular parallelepiped, we have the x-axis, y-axis, z-axis, and we have ijk, the unit vectors ijk along x, y, z axis respectively. So the vector coming out of the surface ABGF will be the vector I, so that is why n becomes I. X value, okay, everywhere on this face the x will be maximum, which is equal to 1. At the same time, x will be a constant, and because x is a constant, dx do not exist, dx becomes 0. So your surface area ds will be dy dz. Okay, so to calculate the double integral, we need f dot n value. F we have, and n becomes I. So we take the dot product between the f value and I. We have I, j dot I and k dot I becoming 0, which leaves us only with I dot I. So our value is 2xy. And at the same time, we have our x value as 1. So 2xy becomes 2y. So that's why the double integral over S f dot n dy dz becomes this value. It is 2y, the function is 2y, dy dz, ds becomes dy dz, and the range of y will be 0 to 2, the range of z will be 0 to 3, which is given in the question, and we integrate, we get the value 12. Okay, now moving on to the next phase, which is OCDE, which is the opposite phase. So along the opposite phase, see the n cap, the unit vector coming out will be minus I, and your x value will be 0 throughout, because at the starting point of the x will be 0, So dx also will be 0. ds will be d by dz, n value minus I. So again we calculate f dot n. The integrand becomes 0. So your integral value 0. Okay. Now moving to the face BCGE, moving to the third one BCDG. BCDG will be this right hand side face, and you can see that the vector coming out from here will be the vector j. So your n cap, your n, the unit vector coming out will be j, and here everywhere along this face you will have your y coordinate maximum. Y is equal to 2, so that will give us y is 2, so dy will become 0. So your ds becomes only dz dx. N becomes j. For calculating f dot n value, you will get 2z square. So we calculate it, we put the value of ds, which is equal to dz dx. X ranges from 0 to 1, z ranges from 0 to 3, and we calculate, we get the value 18. On the opposite side, that is AOEF, your n value will be minus j, because it's in the opposite direction. All along this here, y coordinate will be 0, which makes dy 0. So your ds becomes dx and dz. Okay, so n becomes minus j, ds becomes dz dx. So when you calculate f dot n, you will get the integrand 0, which make the double integral 0. Okay, now we have only the top and bottom faces left. Along the top face, we will have your z value maximum, which is equal to 3. So dz becomes 0. So your ds becomes dx and dy. Okay, so top of the face, ds becomes dx and dy. Z is 3, so dz becomes 0. So again, calculating f dot n, you will get 3x. When you integrate this, you will get the answer 3. And this is a bottom face, at the down face, where you have n will be minus of k, opposite direction. And throughout there, your z value is not 1, your z value is 0. Okay, z value is 0. So your f dot n becomes 0 and the integrand becomes 0, the integral value becomes 0. So now we calculate all the 6 faces surface area and we get 33. So now the left hand side we got 33, right hand side we got 33, and the Gauss divergence theorem is verified. Thank you.